Okay, sixth grade. Before we start today's lesson, just an announcement. Your Chapter 10 test, I have tentatively scheduled for next Tuesday. I know you guys don't like Monday tests, so let's try Tuesday. This is for Matt. I know Adam complains about that too. So tentatively on Tuesday, we will take that. Chloe, yours is probably sticking up back there somewhere. Just go look for those papers sticking up in the folder. You know you only have 10 minutes. Okay. So anyways, we'll finish up today another volume formula. Tomorrow, talk about spheres, surface area, and volume. Friday and Monday will be review days. Okay, so tentatively the chapter 10 test, that's on everything. 10-1 to 10-8 will be Tuesday. After that, I haven't decided yet. We are either going to move to chapters 8 or 9. And Zach, I know you're not here, but I did give you both of those packets, so you will be ready to start either one. But we'll talk about that next week. PSSA review, at some point we are going to do some PSSA problems together. It's not going to be difficult for you, but there's certain things we haven't done in a while or we haven't done this year that I just need to kind of remind you of. Okay? What'd you say? Yes, I have a packet of, they're easy though. Not a ton of them, Melissa, just enough so I know that you guys are ready. Mary? Yes, that is chapter 8. Chapter 8's functions, chapter 9's triangles. I'm leaning more towards going to chapter 8 next. So, Jeremy? No, you're taking the 6th grade PSSA. Yeah, yep. All right, so let's start with the warm-up. Annalise, can you tell us what you got for number 1? 50 feet what? I just didn't hear you. Good. Briar, number 2? No, you're reading it wrong, I think. There you go. Big difference there, right? Okay, number 3, Mary. You said 26,000? No, you're way too high. I'm guessing you forgot to take the diameter and divide it by 2. Okay, Emma M? Okay, I had 45, but around there, depending on whether you use the pi button or not. Adam, number 4. Okay, did you do the calculations? Okay. Good. Good. Okay. So by about 204.34 centimeters cubed is the difference. So feeder A holds more. Number 5, Donatus. Okay. Alyssa, number 5. No. Justin? Yep, 16 inches. Matt, number 6. Yeah. Yes, depending on how you rounded, yes. No. Emma H? Good, 85. I'm guessing you forgot about the 1/2 there. When you do base times height, you have to do 1/2 base times height, which is up the triangle, and then times height of the prism. So I'm guessing you just forgot about something. Okay, that should have worked. Okay, maybe you solved your equation wrong. Before I go over it, go back and try to set it up again. You might have just made a silly mistake. If not, I will go over it. Charles, number 7? No. No. Unless my answer's wrong. Sean? Yeah, it should be 80 yards. Sean, do you have written down how you set that up?
I didn't break it down.
Okay, can you tell us?
119,129.
Good.
Divided by 23.7, and you get 5,027.
Okay.
And then you divide that by 5.
Good.
And get 1,299.
Good.
And you find the square root of that, and you get about 40, but that's the radius.
Good. Perfect. And I have it up there. There was a couple ways to solve that, but what Sean said is perfectly fine. Mary? Okay. Number 8, Justin? Nope. Doug, number 8? Good. 5,820 what, Doug? Good. Number 9, Matt. You're close. Annalise? Oh, no. You're close, though. Charles? Yep. And I rounded mine to 140 meters cubed. So on number 9, so you should have found the volume of the cylinder and divided it by 2. So to do that, you should have done pi times 1.75 squared times 5.1, and then divide that by 2. You get 24.52. That's the volume of half the cylinder. And then the rectangle, you do length times width times height. So 8.7 times 5.1 times 2.6, you get 115.36. So when you add those together, you do get 139 point something something something. I just rounded. It tells you to round to the nearest whole number, so I rounded it to 140. Charles? Number 10 on the back. Well, no, not the back yet, because we're going to do that eventually. What did you get for number 10? You're perfect. Good job. Annalise? Yeah. You're finding volume. Remember, you're finding what... Yeah, but think about it, though. You're finding how much can fit in the cylinder, and you're finding how much can fit in the rectangle. You don't need to subtract anything, because you're just finding how much can fit inside. Nothing to subtract. This is different than surface area. Because you're finding how much can fit in, so it actually works out nicely. If you just find the volume of each of them separately, that takes care of the volume of the whole thing, Annalise, so no subtracting involved. So on 8, for the top rectangle, you do 18 times 12 times 20. You get 4,320. For the bottom rectangle, you do 25 times 20 times 3, and you get 1,500. So then you add 1,500 to 4,320, and you get 5,820. So no subtracting. Right, that's what I just said. Yep. So you have the, here, listen, you have the big fat one, then you have the skinny one on the bottom. I recommend taking the big one on top and then the skinny one that's on the bottom. It shouldn't matter, but it's easier if you take the whole skinny one on the bottom as one, and then I call it the fat one, the wide one that's sitting on top. Okay? Matt? Yep. Okay. And then times h to find the height, right? And then set it equal to 224,400. Did you get the right answer? Oh, gotcha. Okay, gotcha. So I was just going to ask, did you, okay, but you're okay on number 2 now. Okay, you just don't like the triangles, I think. Mary? Did you do 9.4 squared for your radius? And then did you immediately just type in times 3.14 times 24.3, or did you round the radius after you squared it? Okay, then you should get the same thing then. Hold on. 9.4 squared times 3.14 times 24.3. Okay, yeah, never mind. I must have used the pi button when I did this and forgot about it. So you're good, Mary. You're fine. You're fine. I will always have both answers on my answer key, whether you use the pi button or not. Okay. Any other questions on the warm up? Zach, you do not have this warm up. I made a copy of this, so do not worry about this. Just make sure you check your homework. All right, let's go to the homework, guys. All right, 10.7. Regular 10.7. Don't lose this paper I gave you, Alyssa. Nah. You can just check them either with my key tomorrow or check on Blackboard. Okay, so regular 10.7, don't lose that warm-up I gave you. We're going to come back to that at some point, so don't lose that. Doug? I mean, that's up to you. Okay, number 1, Annalise, we'll start with you today. Good, and it says to round to the nearest whole number, so I'm going to round up to 10 centimeters cubed. Briar, number 2. Good. Sean, number 3. Can't talk. Oh, that's all right. I'll come back to you. Adam, number 3. Good. Jeremy, number 4. Okay. Somewhere around 1,767 yards cubed. You okay, Jeremy? Okay. Somewhere around there. Sean, are you ready? Okay, number 5, Emma M. Feet cubed, yep. Okay, number 6, Emma H. Yep. Good job. Number 7, Donatus. $800 and what? You said 23,000? Okay, I have 23,879. Okay, it should be somewhere around 23,879 or 880. Donatus, you're off a little bit, but I'm guessing you used the pi button. That's why. You're fine. Annalise? Yeah, I have 0.72. Yep. I thought these directions. You know what? I'm still following the directions that tell you to round to the nearest whole number. Hey. So that, yeah, it should be 80. But if you have 79, I'm not going to mark that wrong. Okay, Sean, number 8. Good. Matt, number 9. Yep, good job. Justin, number 10. Good job. Doug, number 11. Good. Number 12, Mary. Good. Safe B. Safe A had 81,000 centimeters cubed as the volume. Safe B had 96,000 centimeters cubed as the volume. Okay, 13. Who would like to tell us what they got for 13? Matt, what'd you get? Good. I had 6,757, but same deal. Okay. So, yeah, depending on how you rounded there. All right. Oh, and if anyone did 14 for some reason, it should be 18,144 centimeters cubed. If you wanted to try it, it really was easier than 13, but Donatus? Okay, you should not be off on me on this one because there's not a pi button. So you should, that's actually not right. Maybe you multiplied something wrong? Okay. Okay, Annalise? Yep. That's why, no subtracting. On volume, remember, you're just finding how much can fit inside. There's no subtracting. You're just multiplying for each of them and then adding all them together. Because if you find how much stuff can fit in each part, that's the same thing as adding it all together and finding out how much stuff fits in the whole thing. Okay? What'd you say? Yeah. It's 18,144 centimeters cubed. Matt. Number 8. Okay. Let me see here. Okay. So you need to subtract. So you need to find the volume of the mailing box, and then also what it's surrounded by. So you need to find the volume of each. They want you to find how many cubic inches are there for the foam packaging. You shouldn't be adding them. You want to subtract because you want to see how much space there is between the mailing package and what's actually in it. You will do something like that in real life, but you might not find the volume of it. Okay, hold on one second. Are you okay on 8? Okay. Number 10.6, number 11? Well, that's very random. Okay, you should get 829 millimeters squared. That's funny. I typically have all these done, so if you guys need other answers, let me know. Mary?
For 7, I got it.
7? Okay. You should just be doing pi times 13 squared times 45. Or like you did in the warm-up, maybe you kept the diameter and you forgot to find the radius. Okay, yeah, maybe you forgot pi. Or you didn't square it. I'm not sure. All right, anyone else on homework or warm-up? Adam? Yep. Okay, so for half the cylinder, did you do half the cylinder volume formula? Okay, you should get 2,797.7. And then for the rectangle, I'm sure you probably didn't write your work down, but for the rectangle, 3,960. Okay, so then do the cylinder thing again. Pi r squared h, and then divide it by 2. Okay? Doug? Yeah, that's what we were talking about with Donatus. Yep. All right. Give me a thumbs up, thumbs middle, thumbs down on volume that we talked about yesterday. Okay, so in general, what is the formula? In general, Sean? Good, but even more general than that. Good, because what you said is not always true for the triangular prisms as well as the cylinders. So volume of all 3 figures we talked about yesterday is B times H, area of the base, times the height. What's one figure we talked about yesterday? Matt? Good, rectangular prism. Mary, what was another one? Good, cube. What was another one, Sean? Good, cylinder. What was the other one? Alyssa? Good, triangular prism. Okay, we're going to focus on 2 more today. Adam? We're getting there, okay? So let me shut one of these lights off so we can see a little better. We are going to talk about pyramids and cones today. Kind of like yesterday, this is not going to take me long to explain to you. I am skipping around. I'm not a big fan of these notes, so I'm skipping around a little bit, okay? So 10.8 is where we are in your packet, and I'll tell you what the page is in a second here. Yes, thank you. 34, but don't read all that stuff that's there. We're not doing all that. We're not doing the exploration. Okay? We are going to start with on page 35. Yes, go to page 35 where it says summarize your investigation. Here's what we're doing. We're actually just going to talk about it. Okay, so what I want you to fill in here is the volume of a pyramid is 1/3 of the volume of a prism. If the pyramid and prism have congruent bases and the same height. So I'll say that again. If we were to do like a discovery lesson, you would have figured out that the volume of a pyramid is 1/3 the volume of a prism if the pyramid and the prism have exactly the same, in other words, congruent bases, and the exact same height. So the formula for a pyramid is volume equals 1/3 B, capital B, which is area of the base, times the height. Write this where it says formula, put a box around it. It's just like yesterday, but use your common sense. A pyramid is smaller than a prism. It only has one base, so you just put 1/3 in front of it. Okay, raise your hand next time, but go ahead, Adam. Yeah, instead of multiplying by 1/3, you could just divide by 3. This goes back to that area of a triangle formula that we've talked about. Same deal. Donatus, may I ask what you're doing? If you lost your notes, there's some more in the back behind Charles. Okay, it's an orange. There you go. You got it. Page 35. Okay, second part here says the volume of a cone is 1/3 the volume of a cylinder. If the cone and the cylinder have congruent bases and are the exact same height. So same deal, volume equals 1/3 area of the base times the height. If you want to get more specific, like I usually use this one, but if you want to get more specific, you could write down 1/3 pi r squared times h. Annalise?
Well, then would you have to just call these into the area
We're doing volume, not area.
Yeah.
But no, you don't need to have a cylinder there. They're just comparing it so you know where the formula comes from. No. This was as if we did a discovery lesson today and I had figures in here for you to actually find volume of, and I had you discover the formula of the pyramid and cone on your own, you would come up with this. But I don't want to waste a day. Not that that would be wasting a day. I just don't think that's necessary with you guys. A lot of you know it anyways because you're doing it in science class. So that's why that's on there, Annalise. It's just so you have something to compare it to. You don't need it there. This is the formula regardless of what you have next to it. Raise your hand if you knew that. Oh, you guys didn't know that. Oh, okay. All right, let's flip over to the next page. I want to do some examples. Okay, I would like to start with on the next page, which is page 36 in your notes, number 1. Okay, stay with me here because I'm not doing all of these. All right, so number 1, these are some very interesting problems. Would anyone like to read number 1 for us? Emma H, go for it. Harlem Shake, Emma, go for it. Good. I'm surprised they asked us that, aren't you? All right. So here's my great drawing of a pyramid with a square base. So go ahead and attempt to draw something like that. It's helpful if you know what they're giving you. And I don't know. I like to see it. Some of you guys, I know, just do it in your head or do it on your calculator, but I like to see it. If it's a square base, we know all these sides are congruent. Okay. It is a pyramid. We're given the height is 100, and these are all in feet. Me? I'm not quite sure about that. I'm not very good at drawing. Okay, so without looking back at the previous page, Jeremy, what is the volume formula? Just the general volume formula of a pyramid.
1/3 base times height.
Very good. Awesome. Okay, so 1/3. Briar, how do we find the area of the base? Good. 200 times 200. Charles, what is the height? Good. Yes, you guys could put 200 squared, same thing. So I'm going to let you guys do this part. So you can either take 200 times 200 times 100 and then divide by 3, or multiply times, put in parentheses 1 divided by 3. Do not put in 0.3. 1/3 is 0.3 repeating. That's a big difference. Mary, what did you get? Was it 0.3 repeating?
Yeah.
Okay, thank you. So no matter what way that you do it, you're going to get that. I need to put my hat on my 3. You're not always going to get a decimal. Not always. No, not always. In the next one, we're not. Okay, shh, listen. Questions. Charles? I don't know. This was in your book, so I'm guessing it's true. Because I don't think your book would make that up. But, shh, hey, Doug and Emma, got to raise hands, okay? Quit yelling out. No, not you, this Emma. Sorry. Emma M. Emma H. Harlem Emma H. You're good. Harlem Emma M. Hand up. Charles, if you want to Google it or check, I'm sure, or I will, I'm sure it'll tell us. Are you on? Oh, you're looking at number 2. Yeah. All right. I didn't know what number you were talking about. Okay, number 2, Mary. Go ahead.
There's a typo. It says
Yeah. Yeah. All right. Number 2. Charles, could you read number 2 for us, please? Yeah. Good job. Okay, I want you guys to do this one on your own. Okay, we know that the base is square. We know it has a height of 480. This one you will not get a decimal. So Briar, I promise you will not always get decimals. Okay, I'll see it later. Yep, when you guys get it, just put your hand up. Okay, Sean, what did you get? Answer first. What, 90 million what? Okay, and then Annalise, can you tell us what the fill in for the formula? Tell me what to fill in though, like how do you find area of the base? What did you multiply? Okay, and then what was the height? Good. Okay, so there's our answer for that. So no decimal. Emma M? Yeah. Yeah. Oh, really? Ooh, cool. Okay, so Charles, this must be correct. Very cool. I like that. I like that you're connecting that. You got to tell your social studies teacher that we figured that out in math. It's correct. Very cool. All right, Charles. Thanks. I will remember that. Just another unit. All right. Okay, guys, let's go to number 5. All right, number 5. You decide to use a cone-shaped container to sell ice cream for some reason. If the radius of the base is 6 centimeters and the height of the cone is 12 centimeters, how much ice cream will the container hold? So we know that there's a radius of 6 centimeters, and we know the height is 12 centimeters. Volume of a cone in a pyramid is always 1/3 base times height. So Adam, what are we plugging in for area of the base? How do we find it? Good. And then all of it times 12, which is the height. So I would make sure that you square the radius first, and then multiply it by 3.14, then multiply it by 12, and then either divide by 3 or multiply by 1 divided by 3 in parentheses. When you get an answer, put your hand up. Briar, what'd you get? Good. Centimeters cubed. Good. Okay. Questions on that one? Charles, questions? What is F? Oh, okay. We're going to use, the reason I asked, we're going to use the letter F to represent function notation in chapter 8. All right. Number 6, I would like you guys to do. Okay, go ahead and do number 6. What's wrong? It's not, 1/3 is not 0.3. 1/3 is 0.3 repeating. Remember I said that? 3/10 is 0.3. Okay, but 1/3 is 0.3 repeating. Big difference. Wait, say that again? What are you asking me? I don't. He's just confusing us all. He's keeping class interesting. Donatus, he's ahead of us, so he's figuring out something to keep him occupied, right, Charles? I mean, I can make it harder if you guys really want. No, that's not fair. Good. Good. Yeah. Oh, I love it. That is unbelievable. You make sure you save that.
Except this isn't my calculator because
Where's your answer though? You need to find the volume of it though. Yeah.
I need to make it. I need to make
Hold
it.
on. Yeah.
This actually isn't my calculator
Uh,
because
you need Adam. You still need to write down what it is. Okay, guys, in your seat. Emma. Okay, Donatus, give that back to Mary. Mary, wait for a couple more minutes. Okay. No, Doug, sit down. Charles, stay in your seat. Okay, number 6. So it asks you, does this hold the same amount of ice cream as the previous cone? Why do you think it does or does not? Okay, so no, it does not. What is the volume, Emma H? Good. So Adam, you just had to give a reason why. Okay. Shh. Quiet. Which is by just calculate it. So Emma, you should have 1/3 times pi times 12 squared times the height, which is 6. So you probably just typed it in wrong. 12 squared times 3.14 times 6, and then divided by 3, or times 1/3 in parentheses. That's why. Okay, Charles, what's up? Okay, go ahead. Good job. He's using his calculator. It's just another form to write it. Don't worry about it. All right. Don't worry about it. You don't need to know that. Okay, so hey, shh. Any questions on that? Annalise. No, not now. He can show you in a couple minutes if he wants to. I just don't want to spend time. Tomorrow we need to do sphere. But if there's time, eventually, yes. Okay, Donatus, hold that thought, okay? Hold on. Okay, I need you guys to take your homework packet out and also the warm-up out from today. Shh, quiet. Okay, so regular practice 10.8, numbers 1 to 12, which is all of them. Shh, quiet, yes, you got to raise your hand. So the warm-up from today, which is practice 10.8C, I want you to do 1 to 10. You have about 5 minutes to get started, okay? Zach, just do the regular 10.8 since I didn't give you the other copy. So again, 10.8 is in your homework packet. You're doing 1 to 12. Hold on. You're not doing that anyways. And then 10.8C, which was the back of the warm-up from today, 1 to 10. Annalise? You need to read first what it's asking you, and then you'll know what to do, okay? Depends what the base is. You know what I'm saying? It depends what the base is. Yes. Yes. Don't forget to do the dividing by 3. Okay, guys, hold on. Let me stop this, and then I'll answer the rest of your questions. Yes.